Honors Chemistry, this is a solutions video for lesson 9. It was assigned some time ago, but some students had questions on this and I had not posted an answers video, so I'm going to go ahead and do that now. So we'll get started. The first page is a list of covalent bonds, and your job is to give the name of each of these. Okay, so with covalent bonds we use the following prefixes. Prefixes is a part of a word that goes at the beginning of a word. So these are the numbers 1 through 10 and the prefixes used for them. So 1 is mono, 2 is di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. So those will go at the beginning of the chemical names for each of the elements in the compound. The exception is you don't put mono in front of the first letter. That's because so many times there is just one of the first element listed that it's just kind of pointless to do that. So you don't use mono in front of the first element, but everything else you use depending on how many of each element there are in this compound. Okay, so let's go ahead. So I, of course, ideally try these on your own, but I'm going to go through them fairly quickly. Try them all on your own, see how you do, and then compare to what I do. So carbon dioxide, CO2 is carbon dioxide. So there's 1 carbon, and there's 2 oxygens, so it's di, and then you always end with an IDE. It's not dioxygen, it's dioxide. So IDE always comes at the end of the second. And it's not monocarbon because, as we just said, if there's only one of the first element listed, then it's just that name of that element. You don't put mono, you don't say monocarbon. Okay, this one's water, and there's 2 hydrogen, so you do put the di in front of the first one. It's just mono that you don't. So it's dihydrogen. Dihydrogen oxide. Next one is nitrogen. And then there's 1 oxygen, so it's mon, and then oxide. It's not monooxide. You don't write 2 O's. So whenever you have a vowel beginning the name of the second element, in this case oxygen begins with an O, it's monoxide, not monooxide. Okay, bromine is Br. There's only 1, but you don't write monobromine. And 5, come over here, 5 is penta, so it's pentafluoride. Okay, phosphorus. And there's 3 of them, trichloride. N2 is 2 of them, so dinitrogen. Monoxide. Two sulfur, so it's disulfur. And 2 chlorine, dichloride. Two phosphorus, so it's diphosphorus. Pentoxide. Xe is xenon, one of the noble gases, and tetrafluoride. It's one of the noble gases that actually does form a compound, because we said that generally they cannot bond because they're inert. They have full octets. But some of the ones lower down, like xenon, radon, and such, can form chemical bonds, and tetrafluoride. Okay, and that takes care of that, so be sure you understand each of those. Now we're going to go over and we're going to do some ionic compounds. And ionic compounds are named differently. Ionic compounds contain a metal and a nonmetal. The metal gives up electrons, so that's everything in these left column are metals, gives up electrons to obtain a positive charge. Remember, it wants to be like the nearest noble gas, and metals give up electrons to do that. The nonmetals here in this column want to gain electrons to be like the nearest noble gas. So the first thing you do is identify the charge on each of these. And so you can do that for some of them just using a regular periodic table, but for some of them you'll need the periodic table of ion charges. Okay, so for any of the alkali and alkaline earth metals, alkali metals being the first column, alkaline earth being the second, you should know that these are going to become +1 because they lose an electron to go backwards and be like the nearest noble gas, which is in the previous row. So for example, sodium loses an electron, loses its third orbital, and then has an electron configuration just like neon with a full second orbital. So it goes backwards. So these two +1, +2, these want to lose 2 electrons to do the same thing. Then these over here in this third column, so over here, they do the same thing. Boron will lose 3 electrons to be like helium, so it'll give up 1, 2, 3 to be like helium, and so these are +3 charges. In the middle, these don't ionize either way. They're 4+, 4-. They could be either direction, but they tend not to ionize. And then over here we get into the anions. These are the ones that gain electrons. So nitrogen gains 3 electrons to be like neon. Oxygen gains 2 electrons to be like neon. Fluorine gains 1 electron to be like neon. Similarly, phosphorus gains 3 to be like argon. Sulfur gains 2 to be like argon. Chlorine gains 1 to be like argon. So these are minus charges. These are the anions. Okay, or you should be able to figure those out on your own. But for all of them, you have this charge numbers of ions, so +1, +2, what we just said, +3, nothing for this column, and then -3, -2, -1. Okay, the ones you really need this table for are the transition metals and some of these other metals, which may have more than one charge, and you cannot figure those out. There's no way to figure out that iron is a 2+ or a 3+. You have to have this table. Okay, all right, so let's go ahead. So sodium and oxygen, let's just do this with a regular periodic table. So sodium, Na, is a +1. Oxygen is a +2. It wants to gain 2 electrons. So we write that right here. And so just write it up above as a superscript, little number up above of sodium, and the charge for oxygen up above. And then you just do the crossing arrow. The 2 on oxygen goes to sodium. The 1 on sodium goes to oxygen, but you don't write it. So it's Na2O. In other words, you need 2 times +1 equals +2, and 1 times 2- equals 2-. So you got 2+, 2-. An ionic compound needs to be electrically neutral. So that's how you get there. And this would be called sodium. You don't change the name of the cation, the first element, and you change the name of the second one to oxide. You notice you don't use the prefixes for ionic bonds. It's not disodium, and it's not monoxide. That's only for covalent bonds. For ionic bonds, they name them differently. So it's sodium oxide. Okay, calcium. 2+, phosphorus 3-. So calcium's right here, so it's going to be a 2+. It loses 2 electrons to be like the nearest noble gas. Phosphorus gains 3, 1, 2, 3 to be like argon, to be like the nearest noble gas. So right here, it's Ca 2+ charge for calcium, a 3- charge for phosphorus. You just cross the arrows. So calcium becomes a 3, phosphorus becomes a 2, and it's called calcium phosphide. Again, you need 3 calciums at 2+, 3 times 2+ is 6+, and you need 2 phosphoruses at 3-. 2 times 3- is 6-. So you have 6+, 6-. That's electrically neutral, that's balanced. Manganese oxide. So manganese is right here. Whoops. We're going to need this one because it's a transition metal. And manganese can be either a 2 plus or a 4 plus. So in the cases where there's more than one, I'm going to have to tell you which one, what the charge is going to be on that. You cannot figure that out. Okay, so manganese is a 4 plus, oxygen's a 2 minus, so you cross the arrows, and you end up with Mn2O4. So that would actually, I'm going to write it over here, Mn2O4. But when you can reduce it, just like reducing a fraction, they have a 2 and a 4 in common, so you can divide this by 2 and get 1, divide this by 2 and get 2. Your final answer will be MnO. So it's Mn1O2. Okay? And that's manganese 4. You have to state which one if it has more than one possible charge. And oxide is 1. Okay, so again, the 4 plus and the 2 minus reduced to 2 plus and 1 minus. Okay, so there you go. Okay, think about that one if you need to, all right? Okay, lead. Lead can have more than one charge, so we're going to need to come over here. There's lead down there. It's either a 2 plus or a 4 plus, so I'm telling you here it's going to be a 2 plus. Nitrogen is always a 3 minus, okay, right there, 3 minus. So you come over here, you put the charge above the lead, it's 2 plus. Put the charge above the nitrogen, it's 3 minus. You cross the arrows, lead becomes 3, nitrogen becomes 2. So it's lead 2 because, not because the number here, don't get confused. Sometimes students put lead 3 because of that. No, it's lead 2 because of the charge. Okay, so it's lead 2 nitride. All right, so 3 times 2 plus is 6 plus, and 2 times 3 minus is 6 minus, 6 plus, 6 minus balances. Okay, now the rest we're going to do, and I'm going to do all of these with you, so try to do them on your own, okay? Just give it a shot. Try to do them on your own. Okay, potassium is going to always be a 1 plus. Sulfur is always going to be a 2 minus. So that means you don't have to use Roman numerals. If there's only one possible charge for the metal, you don't have to use Roman numerals. So we're going to write K, 1 plus, S, 2 minus. We're going to write K here, S here. This comes over here and becomes a 2. And the 1 comes over here and becomes a 1, which you don't have to write. So you need 2 positives, that gives you a 2 plus, to balance with the 2 minus that sulfur has. Potassium sulfide. Lithium. Come over here, lithium's a plus 1. Nitrogen is a 3 minus. Alright, you got that. Alright. Lithium and nitrogen. Okay, the 3 comes over here. The 1 comes over here, which you don't write. So it's lithium 3 nitride. Well, it's lithium nitride, excuse me. It does have 3. You need 3 of the plus 1s to balance off with the 1, 3 minus, 3 plus, 3 minus. There it is, lithium nitride. Strontium and chlorine. Strontium is right here. It's a 2 plus. Chlorine is right here. It's a 1 minus. So it's just SrCl2, strontium chloride. Gold, 3 plus, so that has more than one charge, so we needed to tell you which one. There it is, Au. It could be a 1 plus or a 3 plus, so we're going to use the 3 plus. And fluorine is a 1 minus. You can get that off the periodic table. So it's AuF3 is the chemical formula. Cross the arrows. Okay. Again, you don't have to write the 1. So it's gold 3 fluoride is the way you would say that name. Titanium, right here, 3 plus and 4 minus. So I have to tell you which one we're going to use. 3 plus, 4 plus. It's always plus. Metals are always plus. Okay, so we're going to come over here, and oxygen is always a 2 minus. Okay, so we cross the arrows. So Ti2O4. So you need 4 times 2 minus to give you 8 minus, and 2 times 4 plus to give you 8 plus. But again, this can reduce. So I'm going to write that down here, just cut like you're reducing a fraction. 2 goes into both 2 and 4. So the titanium reduces to 1 and the oxygen reduces to 2. There's twice as many oxygen atoms as there are titanium atoms, and so we reduce it down to TiO2. So titanium 4 oxide. Okay, zinc. What about zinc? It's a transition metal, but if we look at it, it only has one possible charge. So we don't have to use a Roman numeral. And this one's pretty easy. You can see it's a 2 to 2, which is a 1 to 1 relationship. So Zn2O2, but you can reduce that down to just 1 to 1. So it's zinc oxide. Again, you don't need a Roman numeral because zinc only has one possible charge. Okay, keep going here. Nickel. Nickel has a couple of charges, so there it is. It's a 2 plus and a 3 plus. So we're going to use the 3 plus here. And sulfur is a 2 plus, or 2 minus rather. 2 minus. So it's Ni2S3. 3 times 2 minus is 6 minus, 2 times 3 plus is 6 plus, so that balances. Okay, so it's nickel 3 sulfide. Rubidium, let's find that one. That's not a very common one. It's right there though. It is an alkali metal, so it's got only one possible charge, and that's going to be a 1 plus. And phosphorus has one possible charge, and that's a 3 minus. So it's Rb3p, okay, 1p, so crossing arrows. Okay, rubidium phosphide. Okay, finally one more, tin, and tin has more than one possible charge, and it is abbreviated Sn, which is right there. So it's in the other metal category, but it is a metal, so tin, 2 plus, 4 plus. So I gave tin a 4 plus on that one. Bromine, right here, is a 1 minus. Okay, so you need 4 times 1 minus to give you 4 minus, and you need 1 times 4 plus to give you 4 plus, so those are in balance. So it's at tin bromide, and the way we write the name though is tin, and it's tin 4 is the charge, so tin 4, IV. The V is a 5, the I is a 1. When you put the smaller number in front of the bigger number in Roman numerals, it means that you subtract it. So 5 minus 1 is 4. So tin 4 bromide. Okay, so that's that. If you made a few mistakes and you've already turned in this assignment, because it was actually due a few weeks ago, or a couple weeks ago, that's okay. If you just didn't get it at all, then I would redo it and go ahead and resubmit that, okay? Because now you have every single answer.